All right, we're picking up in Chapter 4, Section 4, about factoring polynomials. And we're going to talk about the factor theorem. We've talked about theorems before. Theorems are just widely accepted mathematical ideas that have shown to be correct over and over again, so they're basically considered truth. So we got some math speak up here in the top, which is f of x divided by x minus k. We've talked about that when we did the remainder theorem. Some polynomial divided by a linear term, or a linear polynomial, x minus k, equals the quotient plus 0 over x minus k, which is just quotient. If you get a 0 for the r, the remainder, 0 divided by anything is just 0, so it's just the quotient. Basically what this is saying is that if you divide a polynomial by a polynomial and the result is a remainder of 0, then it is a factor of that polynomial. So you can prove something's a factor of a polynomial, like when we are factoring quadratics. If you're not sure if someone says, hey, x plus 2 might go into that. If you're not sure it's a factor, you could divide it, long division or synthetic division, and prove it. Like this. Determine whether, on question A, x minus 2 is a factor of f of x equals x squared plus 2x minus 4. Now, we could just factor x squared plus 2x minus 4 and figure out what the factors are. But we want to show it. And the main reason is if we can do it on the small one, and when we get to b and it's not a quadratic anymore, and we don't want to factor it, factor by grouping or something like that doesn't work, then we could prove that it is. So let's look at A. We're going to take x squared plus 2x minus 4, and we're going to divide it by x minus 2. And since it's an x minus 2, I'm going to do synthetically, so I'm going to put a 2 in there. That's 2, 1, none. Everybody's there, so 1, 2, negative 4. Drop the 1. 2 times 1 is 2. That makes 4. And 2 times 4 is 8. And that makes 4. So that would be x plus 4 divided by x minus 2, which would tell me it's not a factor. And we could prove that. We could try to say, okay, if we do x squared minus 2x, or plus 2x minus 4, and we tried to factor it. Factors of 4 that subtract to 2, where you got 1 and 4, and you got 2 times 2. 4 minus 1 is 3, 1 minus 4 is negative 3, 2 minus 2 is 0. It doesn't factor, actually. So this proves that it doesn't actually work. Now let's look at B. We got 3x to the 4th plus 15x to the 3rd minus x squared plus 25. We could try to factor that by grouping, but it may not get us very far. But if we do a divide by x plus 5, we could show that x plus 5 is or isn't. So I'm going to pull out the negative 5, opposite to get out. Coefficients, to the 4th, to the 3rd, to the 2nd. We don't have to the 1st. I need that. And then there. Drop the 3. Negative 5 times 3 is negative 15. That makes 0. Negative 5 times 0 is 0. Negative 1. Negative 5 times negative 1 is 5. Makes 5. Negative 5 times 5 is negative 25, which is 0 remainder. So yes. Technically, I guess over here in red, no was the answer. It does not. And over here, yes, it does. And what it results in is 3x to the 3rd plus no x squareds, but minus x and plus 5. That's our leftovers. This is not necessarily the part we need. We need yes or no. Is it or isn't it? This one passed the test. And that mainly because that's 0 right there. This is why it's a no, 4. Okay? So, show that x plus 3 is a factor of x to the 4th plus 3x to the 3rd minus x minus 3, and then factor completely. So not only show that it works, but then keep going. So we're taking x to the fourth plus 3x to the third plus 0x squared minus x minus 3. Now everybody's there. Divided by x plus 3. Okay, so in my little half box is a negative 3, and then we got a 1, a 3, a 0, a negative 1, a negative 3. Separate, drop. Negative 3 times 1 is negative 3. 0, 0 times anything is 0. 0 plus 0 is 0. Negative 3 times 0 is 0. Makes negative 1, and that makes positive 3, which makes a 0. So yes, it is. Okay, and so we know that x plus 3 times, and let's see, that's the constant, so that's the x squared, and that's the x to the third. We know that x to the third minus 1 times x plus 3, and we have to factor completely. Well, this is a cube minus something. We could do it cubed because 1 cubed is cubed. So it's x plus 3 times a little parenthesis that matches, times a bigger parenthesis that's opposite, and then plus at the back. X and a 1, x squared, x, 1 squared is 1. And we are factored completely. Now, because the x-intercepts of the graph of a function are the zeros of the function, you can use the graph to approximate the zeros. If you use Desmos or the TI-84 or graphing calculator of your choice and you graph the equation, where it crosses the x-axis are the zeros, the solves, the solutions, the answers, the intercepts, the what they're looking for when they say figure out what this equation is. Okay? So we can use something like Desmos to our advantage to solve a problem. They have a picture of the graph on here already. So we can check that an approximation is or isn't a solution. So during the first 5 seconds of a roller coaster ride, so from second 0 all the way to second 5, the function h of t, because it's going to be about height, equals 4 times t to the third, t is a time, minus 21t squared plus 9t plus 34 represents the height h in feet of the roller coaster after t seconds. How long is the roller coaster at or below ground level in the first 5 seconds? Our word problems are getting more and more involved. We have to do more steps to get to the answer, so it's always a good idea to write down the answer so you have somewhere to plug it in and make sure you got the right thing at the end. Anyway, so we want to know how long is it below, let's see, and I'm going to underline how long. How long at or below ground level. That is not the word level. Hello. Level in first 5 seconds. So, and I'm going to put a little blank here to fill it in. The first 5 seconds, we're talking about from here to there. At or below ground level. Well, ground level is at 0. So 0 is right here. So we're looking at from here to there. That's where it goes below. Okay? How long is it at or below in the first 5 seconds? We don't have to do this one because it's not in the first 5 seconds. It's behind time. So we don't want to do that. So we only want to look at those. Well, they got one right here, and that's 2 things in. So we think it at least starts at second number 2, and we can confirm that by synthetically dividing it to make sure that it's a factor. So we could say, well, if x equals 2, that's like saying x minus 2. Okay, opposite to get in, opposite to get out. So in our little half box, if it's x minus 2 in the parentheses, we're going to use the 2. Remember, we want to use what x equals. And so we're going to use a 4. That's to the third, negative 21, that's the squared. And we got 9, so 3, 2, 1, and 34, none. Drop the 4. 2 times 4 is 8, which makes negative, let's see, 8 to 10 is 2, 10 to 20 is 12 then, because that's 10 more, and 1 more makes 13. Negative 2 times negative 13 is negative 26. And if we're going to do that, that's going to be a negative 17, which makes negative 34, which makes 0. So yes, 2 is a factor. So we know at 2 seconds. We guessed because the graph, and I'll erase it so you can tell, the graph kind of looks like it crosses at 2 seconds. Now we know it definitely does cross, that this is at 2. Now what we don't know is what this guy is, and I'll erase that a little bit so you can see, but we do know we're going for these spots, right? It's, let's see, 2, 3, 4, it's not 4, and it's not 5, it's somewhere in between there. So what we've got left over here is 4x squared minus 13x minus 17, and if we factored that, we would know the other places that it hits. We actually do know another one, possibly. If we look, it looks like it hits at negative 1. So we could do another divide and divide negative 1 out. We could also just factor this. Now I'm going to have to multiply. I'm going to do slide and divide, multiply 4 times 17, or I could work with a negative 1. So I'm going to try to divide the negative 1 into that guy. So negative 1 goes in there, and I do 4, and I do negative 13, and do negative 17. Drop the 4, because I can see on the graph that's got to be one of the x's, right? So I got negative 1, so I drop my 4. That makes negative 4. That makes negative 17. Negative is positive. That's a 0. So yes, negative was 1. And now I am left with 4x minus 17. Okay, I can solve for that. Set it equal to 0, solve for x. Add 17 to both. 4x equals 17. Divide by 4. X equals 17 over 4. So I've got from 2 seconds to 17 over 4 seconds. Let's shrink that down a little bit. Let's see. What is 17 divided by 4? 4.25. Okay. If we want it in fraction form, we can do that. 17/4 doesn't really help us. Let's look with the 4.25, right? So it goes from 2 seconds, I'll do it in blue, to 4.25 seconds. So how long does it take to get from 2 seconds to 4.25 seconds? Well, it takes 1, 2, and just a little bit more. So it's 2.25 seconds is how long it is at or below ground level in the first 5 seconds of its journey. Okay, so what we did is we used the graph to see places that are really exact, and then we used our dividing to confirm that those are there. We could have done the slide and divide thing with factoring, and we should have gotten an x plus 1 and then the 4x minus 17. Those would have been the factors. But might as well use the picture. Go with what you know. The only one we have to kind of approximate is that one in between the 4 and the 5 we don't know, but we get that out of that last piece. Okay. All right. Here's some problems. Give them a try. Give it a pause. Try them out. Come back. Let's see how they go. All right, let's look at number 10. Determine whether x minus 4 is a factor of this. Let's see, squared first, none. Okay, so there's my deals. Opposite to get out is a 4, a 2, a 5, a negative 12. Separate. Drop the 2. 4 times 2 is 8. 5 and 8 makes 13. 4 times 13, 40, and 12 is 52. And so we get 40. That's going to be no. No, it is not. Let's look at 11. Show that x minus 6 is a factor of this, and then make sure you go all the way. So in my little half box, I'm going to go with a 6, opposite to get out. To the third, to the second, to the first, to the nth, I got to add a 0 at the back. So 1, -5, -6, and 0. Got to have that constant on there. Got to count all the way down. Drop the 1. 6 times 1 is 6, makes a 1. 6 times 1 is 6, makes a 0. 6 times 0 is 6. That goes 0. Nope, it's a lie. That's a 6. Now we'd expect that if it was a factor, then we would have to factor it completely. So let's make sure that I did all that right. To the third, to the second, to the first, to the nth. X minus 6, opposite to get out. A 1, a -5, a -6, and a 0. Drop the 1. 1 times 6 is 6. -5 and 6 is 1. 6 times 1 is 6. -6 and 6 is 0. 6 times 0 is, haha, there's a math problem, 0. See, it happens to everybody. Just go back and check your work. They said factor completely, so I'm going to assume I have to do it. So I definitely did something wrong, and I double-checked my work, and I did find something wrong. So start at 1 less. That's x squared plus 1x plus 0. So we have x minus 6, we confirmed is a yes. And then what we've got left over is x squared plus x. Well, what we can factor out of there is they both have an x. So I'm just going to pull it all the way to the front and say x times x minus 6 times x plus 1. Those are all my main factors. Okay. Now, in example 7, does your answer change when you first determine whether 2 is a 0 and then whether -1 is a 0? Justify your answer. Well, that's because of the way they worked it in the book. No, because we determined both, right? They determined -1 first and then 2 afterwards. We did 2 first and -1 afterwards. We still got the same answer. So if you check what they did in the book, they did it backwards. So, no would be the answer to that one. Okay. Use the graph of the quadratic, or of the polynomial, however big it is, to find x's, zeros, solves, solution, answers, intercepts, where it crosses the x-axis, that you know for sure. Those become your x equals some number, which turns into x minus that number, right? You can make them into your factors. And then whatever's left, you can divide them away from your big polynomial. Break it down into a piece that you can actually factor yourself, or get it all the way down to the bottom. You factored completely. You can solve for all of the x's, the intercepts, the solve, solution, answers.